It's nice to see so many of you here. I was told by the Microsoft DPE guys that you guys throw the best party, and this is normally the time that everyone disappears to put on their makeup and get dressed up and stuff. So it's nice to know you've already done that ready for this presentation, so you can just come and hear me talk. My name is Lewis Benj. I'm a solutions architect at Datacom from Sydney. So please excuse my accent and if I say anything wrong, because I always get corrected. I'm actually British, so my accent's worse than most Australians as well. So I'm here talking about moving applications to Windows Azure. At Datacom, I primarily focus on retail and e-commerce applications, so I've dived around it in Azure quite a lot for its load capabilities of when we're scaling up e-commerce applications. So specifically, we're looking at web-based applications today. So this is tips and tricks for migration. Just out of interest, who's actually played around with the Azure API? And no one? So I'm just going to cover a quick intro to Azure, first of all, just in case you're completely new to it and you don't understand some of the concepts that go on in the API. Then I'm going to look at exactly how we're going to move the application across. So I'm going to use the infamous tailspin travel application that you would have seen in virtually every other .NET session that's on this week. And I'm going to actually just move it. It's an MVC application, and I'm going to stick it up in Azure. We're going to look at some of the tips and tricks along the way, like diagnostics and performance. We'll look at return on investment as well, following on from some of the things that are in Azure and SQL Azure. And then if we have time at the end, we'll just take some questions. I didn't realize there's animations on my slide deck. So, quick introduction to Windows Azure. Windows Azure is Microsoft's cloud offering at the platform as a service level. So, if you're not familiar with the jargon, the cloud is actually divided up into three different things. You have infrastructure as a service, which is just having access to a raw virtual machine, exactly the same as Hyper-V and VMware. Spin up, have to install everything yourself. Next level up is platform as a service. This is typically a development environment where you can deploy an application and it will just work. For Windows Azure, that's Windows with IIS 7 and .NET 3.5 or .NET 4. It will also run things like PHP and Java that runs in IIS as well. It's exactly the same as something like the Amazon platform as well. Amazon offer a platform as a service for developers as well. The next level up in the cloud is then software as a service. So typically that's your application that's built on top of Windows Azure, something like Windows Hotmail or Windows Live Services, and then they're sold on a pay-as-you-go basis. So Windows Azure is essentially a virtual machine. It's hosted on a modified version of Hyper-V, and when you actually spin up a Windows Azure instance, you get a Windows virtual machine with IIS out of the box. It's provisioned using an API, which is available to you via Web Portal, via MMC, and actually now in Visual Studio 2010 as well. And you need a Windows Live ID to actually sign in, and then off of the back of that you can actually use X509 certificates for authentication as well. Primary reason people are moving to Windows Azure is the scalability aspect. So when you install a Windows Azure instance, you can define the load that instance is going to take, so the processing power and the memory utilization. But you can also deploy multiple instances. These instances can actually be deployed automatically, so you can actually use things like diagnostic tools to look at the load on the current instance and then spin up instances on the fly. Or when you actually build the application, you can just deploy in one go and say, I want 2, 3, 4, 5 instances. The way Azure is actually built is it's built on what's called a fabric. It's a jargon now used for a lot of things nowadays, but the fabric is actually the API underneath that allows us to actually talk to the different components within Azure. This fabric is also responsible for things like detecting failures and making sure that if your machine goes down, that then there's a failover onto another virtual machine instance. All of these Azure services are fully load balanced, and the load balancer itself is just round robin. It will deploy to whatever instance it comes across first, and it doesn't manage any type of state of session. So when you're looking at moving applications across, you have to look at persistence, because if you deploy more than one instance, as soon as it switches, you need to make sure that all that state's managed somehow. Azure has fully managed DNS. You get a CNAME when you actually create a Windows Azure instance, and then all the internal IP stuff is taken care of. All you're dealing with is just the application layer. You don't have to deal with the operating system, IIS, or anything like that. When you actually look at IIS, you're running in an integrated pipeline mode, so exactly the same as you get out of the box when you install IIS on Windows 2008, and all your applications run in full trust. As I mentioned, the biggest purpose for this type of application at the moment is the elasticity. So the ability to scale up, scale down automatically, and use things like the CDN as well to replicate and remove latency in applications. So when you look at Windows Azure, the actual architecture of it at a hardware level, this is what it essentially looks like. You have multiple VMs deployed on a big Hyper-V host. These things, if you've ever seen a photo of them, are literally containers. They're the same containers, same size as what you see containers being loaded on trains and boats, and they're just full to the brim with servers. All shared resources, and when you commission a VM, you actually get committed hardware. So it's not shared hardware, but you actually commission use of a dedicated CPU, which is why you pay per CPU per compute. When you expose web instances on Windows Azure, like I said, you get fully load balanced, and that's exposed via HTTP, HTTPS. You have a choice of two different instances you can deploy in Windows Azure. You have the web role or the worker role. So the web role is essentially your IIS website. So it's anything that's going to be exposed to the public. This can be WCF, it could be website, or anything else that can communicate via HTTP, XML, SOAP, and is hostable within IIS. You also then get what's called a worker role. So the worker role is for asynchronous processing of tasks. So this can actually be Java, Ruby, .NET, and it will just take a message that comes in from the web role, and it will just process and do whatever it needs to do. So this isn't typically for long-running processes, for workflow and things like that running in the background. The worker role can actually be communicated with via TCP and HTTP, but has no exposure to the outside world. So all the communication for worker role has to be funneled through the actual web role instance. Both the web role and the worker role can have access to outbound internet connection. So the worker role can actually call things like web services for external validation and interline of business systems. Each instance you spin up, as I said before, is dedicated VMs. So if you spin up two web roles and a worker role, that's going to be 3 VMs with dedicated hardware, dedicated CPU usage on the shared pool. So I just covered some of this, so I'll skip on to the next slide. The other part of the Azure platform is storage. So you have this big compute power, but also you need somewhere to be able to store your information, store your state, store all of your content. So you have a few different methods of storage. So the ones I'll cover today are going to be storage blobs and storage drives. There are also storage tables, which forms a very similar fashion to the NoSQL stuff. So being able to persist relational data on the file system, but I'm not going to cover into that. So storage of blob data is really important because part of the restrictions on Windows Azure is you can't write to a file system. So when you're looking at web apps that are typically used for things like image processing and have to write back images to the file system, or caching information temporarily, or being able to upload documents, none of this is possible in Windows Azure. What Windows Azure does offer is this blob storage system, which is very, very similar to an FTP style system, being able to take blobs of information and upload it, but it's just done through a REST API or an in-process library that you're given as part of the Windows Azure SDK. So when you actually look at blobs, it's very, very simplified in structure. So you have a primary account, a storage account of where you're going to store that information. Then you have what's called a container. So a container is essentially a folder. It's a logical grouping of files. The biggest difference, though, with a container to a folder is it's not just logical, it's actually physical. So it's the grouping of where they're going to get stored on the actual hardware. So when you're actually looking at collating all this information, you just need to make sure that if information is going to be persisted and then retrieved in a logical fashion, you want to make sure that it's on the same hardware so the fabric underneath isn't going to have to look in different hardware locations to actually get this information. Then you get the blob itself. So the blob is, as per a SQL blob, it's a binary object and it can be any type of medium that's uploaded. It also comes up with some metadata, which is normally things like the MIME type and the size. So when that blob's returned, you know what type of object it is that's been returned. So the example here is I'm uploading the blob of Sally and Sally's images and Sally's movies. Because they're going to be collectively retrieved, movies and images, they're going to be stored in different containers, and then I can upload multiple within inside that. The other way you can access blobs is via a virtual drive. Sometimes it's called X Drive, you'll hear it commonly known as. And this is just a similar thing to things like SkyDrive. So it's just accessing the blob storage, but it actually mounts itself as an NTFS partition on Windows. So you can download X Drive software and actually use X Drive software within your web process and be able to communicate as if it is just a file system. The other part of the storage system is queues. So queues are typically the same as MSM queue, if anyone's familiar with that, Microsoft Messaging queue. And this is just typically a way of being able to batch up jobs and communicate between a worker process and a web process. So if you're trying to pass off a lot of long-running jobs, it's easier to queue them up and allow multiple worker processes to pick things off the queue, as opposed to just pass them directly to that worker process. The biggest benefit here is if you have multiple worker processes, the queuing system actually doesn't allow the worker processes to pick off two jobs simultaneously. It handles all of that concurrency. So it means you pass something to the queue, worker process A and worker process B both hit it at the same time. The two jobs can't go out to both servers. So I'm actually going to dive into some code here. So first of all, I'm actually going to talk you just through some blob storage stuff, because this is the biggest change that I found when moving websites across was blob storage. And it's typically involved in images. So I'm just going to switch across to my dev machine. Please shout out if you can't see this. It's a 12-inch tablet, so I'm not sure what the resolution is going to come up like. So what I have here is literally File, New, Cloud Project in Visual Studio. So when you do that, you go File, New, Project. You'll only get cloud stuff if you actually install the SDK as well. So within Visual Studio 2010, you actually get a cloud option. But when you hit File, New, if I went like this and I didn't have the cloud services installed, it would just say, go to MSDN and download them. What I've actually done here is I've created a web project, and it's just a typical .NET page. So on here, I've got an upload control, a button, and a data list. In the code behind, I've actually got some private fields that access the blob client and the blob container. So the code itself is very, very simple. All I'm doing is I'm specifying a location on my file system to upload images, or to upload images from. Once that button's then clicked, it checks that that directory has been provided to me. It then accesses here the actual blob storage account. And if this is live and not on my development environment, it would actually be looking for things like the credentials to actually connect into Azure with as well. It then tells me, then tell it from the storage account details to create a client. And this is the same as creating a proxy in WCF. It's just creating an object you can work with. And all this is doing underneath is it's just using that REST API. So it's just a nice library to actually be able to deal with this without having to deal with the rest. So once you've created the client, you go in and say, I want to get the container. So the container, remember, is this folder. So up here, I've just defined it as a constant. So I'm passing that in, and then the container is returned to me. If the container doesn't exist, I can then create it. So just on the fly, I can specify a folder location I want to store something in, or a container location, pass that in, and if it doesn't exist, it'll go off and create it for me. I then pass in my permissions. So I can actually restrict down blobs to actually say they're private and they can't be accessed outside, or they're public and they can be accessed to things like X Drive. Pass that into the container as well for the creation. Then all I do is I dive into the directory here using system.io stuff, and then go in, get the files out, open them up as a file stream, and then just pass them in here as a file stream and upload them. This is exactly the same as dealing with something like Entities Framework and Link to SQL and passing images into a database. I have to define some metadata, so I have to say this is the file name, the extension, and the MIME type. And the only reason I have to define this is because if I pull it back out, I want to actually know what type of MIME, the MIME type of that object. And then I just loop around for every file and upload to the blob. Upload to the blob storage. Then in reverse, it's exactly the same process. So I actually go in and call this get pictures. I go in and create another, get my storage account details. I create my blob client. And then the blob client will just Again, provide me with the actual, I provide it with the container, and it gives me a list of URIs. Remember, this is a REST-based service, so it'll tell me all the files based on the location in the system. If it's a private system, it'll still be REST-based. It just means they won't be accessible from the outside world. It will only be accessible on Azure. And then all I'm doing is I'm returning these URIs, adding them into a IEnumerable, and then passing it to the data table. I've also got an image handler in there that handles all resizing for me, because some of the images I play around with are obviously large. I don't want the thumbnails to be chucked out at higher resolution. So if I then run this, what actually happens is that when you install these Azure tools, you have something called the development fabric installed in your machine. So instead of it running in the little IIS development server, it actually runs in a localized version of Windows Azure. So you see I've got a few more tools on the side here. And I've got a nice little Windows Azure icon here, and I can actually open up my compute fabric and my storage fabric. So there's one. I'm not sure why the other one's not opening. So this is actually showing me that I'm running all the different storage things. I'm running queues, tables, which I didn't actually talk about, and blobs. And because they're REST APIs, it's given me different port numbers for each one, so I can actually access them if I wanted to. Here's the actual development fabric. So this is actually showing my VMs as they spin up. So as you can see, I've run in a project called Blob Storage, which has one web role, and this is the VM. So there it is there. That's what's actually going on under the covers. So this is really, really great for diagnostics, because I can actually see exactly what's happening here, and I can make sure things are running correctly. So now this is my really basic demo with a spelling mistake on the top. So I can actually jump in, provide it if I can find my location with all my images in, which is at the top of my file. Paste it in, and then hit upload. So what that's now doing is it's going off, pulling all the images out, and then it will upload it into my local Azure Fabric instance, hopefully. So file's now uploaded successfully. It's gone through, done everything under the covers. If I then hit retrieve, it pulls all the images back again, standard Windows images. But if you actually look at the way they're returned, you actually see here that it's being returned off that 1000 port, which is the same as the storage instance here for Blob. And it's just coming back within my container and over a REST-based protocol. The other use for this is content distribution network. So if you're doing things like movie uploads, MP3s, large amounts of information you want to syndicate around the world, the blob storage is available as a CDN, and it will actually replicate it to various data centers around the world. So that's really, really good for mirroring information. So under the covers, you can actually open this up in Xdrive as well. So within this, within the IDE, you get this Windows Azure Management Console, and I can actually open it up and say, in my development fabric, I want to see all my blobs, and then I want to see my image container, which is where I just uploaded all my files to. If I double click on it, it actually shows me all the files. So you can just browse the blob as if it's just a file system. And this is the same for development as it is for the live fabric as well. It will do exactly the same thing. So back into my slides. So if I actually want to move a web application across, it is really as simple as file new project and copy everything in. There's a few things I just need to do to make sure that when I put it up in the cloud, I'm not going to have some issues. So first of all, once I've copied everything into my new cloud project, and it's a web project or an MVC project, but I want to make sure it runs in a local dev fabric. This isn't doing anything to databases, anything to connection strings. It will also be able to access all the resources it would have been able to access if it's running through local IIS. So I just want to make sure it works. The errors I'm typically going to see is I haven't added in the correct system references. I haven't added in, I'm having issues with things like I/O. I can't write to the file system. And it's a really good way just to make sure that everything will run on Azure once it's up there. Once I've got the thing working, I then want to look at data. So I want to be able to move the SQL database across to Windows SQL Azure. I can access SQL in data centers, but if you're dealing with things like CMS, it's easier just to deploy a small database in SQL Azure because it's within the proximity in the same data center of the actual web role. So once that's up, the next thing is then to switch the connection string across to the SQL Azure. SQL Azure, if you was in the session before or other SQL Azure sessions, you'll know is just SQL. It's SQL 2008 on a VM. There's no differences and there's only very few restrictions. You can access it in SQL 2008 R2 Management Studio, and you can access it in Visual Studio to manage as well. All you really need to do if you're migrating to SQL Azure is just switch the connection string to point to the one hosted on the Azure systems. So I switch my connection string, I then go through the same process. I want to test and make sure everything's working in the local development fabric. I then move the application across to Azure, I package it up, and then I try and deploy it into Azure. Azure provides me with things like diagnostic controls to make sure that things are going up correctly, and I can use IntelliTrace to actually dive in as well. So I just want to quickly show you how easy it is to actually move a database across to SQL Azure. So back into a demo. So on Coplex, there's a tool, and I'll put the link up to it in a second, that just does all the work for you. At the end of the day, it's a SQL instance. There. I'm organized, you see, stuff to sort out. So it's called SQL Azure MW. So if I open it up, it's literally a wizard. I can click through and copy from a local SQL instance to the cloud. So what this will actually do is it'll go through SQL and make sure that all of the queries, all the create queries, the indexes, and all of that are actually compatible, and it will analyze that and spit out any errors. It'll do that for indexes, views, tables, stored procedures, the whole lot. You can just run that analysis and make sure things are okay, and then go back in and fix if they're not. You can analyze and migrate, which will do the whole process for you. You can migrate without analyzing if you've already done the analysis once and you don't want to recheck. Or you can just execute SQL against the SQL Azure instance. So if I say I want to migrate my database, first thing it's going to do is ask me to connect to my local database server, which is actually a SQL Express instance. So I should just be able to connect in if everything works okay. There we go. So I have Tailspin Travel as one of my databases I want to move across. So I can click as many as I like and do this all in one batch job if I need to. And I hit next. And it asks me what objects I want to move. Because it's a sample database, there's only tables, there's no stored procedures, complex indexes, or things like that. So I hit next again. This is just a summary. And it says, would I like to generate an SQL script? This is where it's going to do the analysis. It's actually going to go in and create these scripts up for me. So it goes through and actually goes through all the tables, and there's only about 15, so it shouldn't take too long. And it's just looking at currently the airports table. It's making sure that everything's fine to actually go up to Azure, and it throws out a few issues. Typically, I'd actually go back and fix these issues, but I'm not actually going to do that today because it's going to take too long. So I'll just quickly let this run, and then I'll just show you how easy it is to get this thing up into Azure. While I'm doing that, actually, I need to unlock the firewall. So if you haven't seen this before, this is the Windows Azure portal. Again, you sign in via a live ID. And if you're an MSDN holder, I highly recommend you sign up to this today, because at the moment, if you're an MSDN holder, they've just extended the promotional offer for you to have free resource access to Windows Azure for 18 months. That's going to get reduced quite soon to 12 months, so you actually lose 6 months of access to that information. You get a very small amount on MSDN as well, but it's enough to allow you to play around and experiment with some stuff. So once you're in Windows Azure, if you've paid for it, you get access to SQL Azure, and you get access to your server name, where it's located. For some reason, they put me on the US. And you can do things like reset the SAR password. The other issue you'll find is that there's actually a dedicated firewall per SQL instance. So you just need to go in and actually add the IP address you're working on to that firewall. Otherwise, you won't be able to connect into it. So it's really clever, and it tells me my IP address, so I can just go in and add that. Let's just say it's TechUp. and it's this IP range. So this will now allow MySQL Wizard to actually upload into that. You also can go in here and do things like manage the databases as well. You can see here I've got a 1 gigabyte database, and that's all to do with the costing, which I'll get through it later on. So hopefully by now this is completed, and it's chucked out a few errors, but nothing substantial, so I'm just going to hit next. Now it's asking me what I want to connect to, where I want to put this information. So again, go back into here, I copy out the server name. So I just replace the word server with the machine name. I replace it with my username. Sorry. So it's just my username. Then I type my password in. So what that's basically saying is I put the word server in there instead of the machine name, so it's correcting it for me. So it's now going to go off and try and connect to SQL Azure. And it's actually faster than connecting to my SQL Express instance, which is quite ironic. So now I can say which database I want to upload to. But I've already got Tailspin up there, so I'm actually just going to create a new one up. So now this is telling me, asking me which database I want. So this is based on price. So Web Edition and Business Edition are different pricing models, and you get a set limit on how much you can actually use. So I'm just going to use a 1 gigabyte Web Edition because it's CMS and it shouldn't balloon out too much. Hit Create Database, and it's actually just done a Create Database SQL script to add into this. Hit Next. Yep. And now what it's going to do is go up, upload that SQL, execute it, and create all the tables. That's as easy as it is to migrate an application to SQL Azure. The wizard should actually do all that for you. If it has issues with it, the wizard will actually tell you, and you'll need to actually go in and correct it. It's exactly the same as running a create script and actually moving it to another database. So if it won't work, then you just have to go back and actually correct the schema to accommodate that. So that's done. I can now exit. And if I actually jump into Visual Studio, I haven't got SQL R2 on, 2008 R2 on here, so I'll just use Server Explorer. I can actually now connect to a database by typing in my server name. I knew it wouldn't have cached that. Okay, let's try another thing. This is why I've got several Visual Studios open, because it always crashes for me. So paste that in, type my username in. It always requires that @ and the machine name, and it's just to do with the multi-tenancy. If you don't put that in, it won't let you connect. And then I can just literally drop down now, and I'll be able to see, hopefully, take a demo, click OK. And now I can just browse as if it's any other database if it appears in my data connections. There we go. I can open it up. I can now see all my tables have just copied across. The limitations here are around tooling support. Although I can actually put this data connection into to SQL Management Studio and to Visual Studio, and I can see the tables, I can't use things like link to SQL and Entities Framework to generate metadata off of. So what you'll need to do here is actually generate it off a local instance, off a SQL Express or SQL installed on your computer. Make sure that schema is exactly the same, and then just switch out the connection string for the SQL Azure instance, and everything will work fine, which is exactly what I'm going to do with my next demo. It just takes structure. It doesn't take any data across. If you specifically coded it to take the data, then there's no issue, and you can just migrate the data across. Actually, sorry, that's a lie. It did take data, because it takes my username's passwords for my demo. But you can actually opt out of taking the data if you don't want to. This tool is actually not just available for SQL Server. This does it for MySQL and other SQL databases as well. I'm not 100% sure. I'm not a SQL expert, so I can certainly find out for you. And if you leave me your details, I can get someone to let you know. So, no, you don't get charged you get charged for a small amount. If you're on MSDN, they're included. But you normally just get charged data for the SQL hosting. So the connections, internal connections and connections you're doing behind the firewall aren't charged, I don't think. Again, I'm not a SQL person, so any SQL questions you do have and I can't answer, I'm more than happy to pass them on to a SQL person that can. So quickly, just back to my slides. This is the tool I just used, SQL Azure Migration Wizard. It's freely available on CodePlex, very, very easy to use. It's just a single download. So the next thing we're going to look at is actually getting that MVC app onto the cloud. So if you remember back to my previous slide, it's all about we want to make sure the application's working. We want to switch out the connection string to make sure it works with SQL on Azure. And then we want to bring it into the local dev fabric, make sure it works, and then actually then put it into the cloud. So again, back to the development machine. So you'll be really, really familiar with the application that I'm using. Oh, look, Emma. So if I just quickly show you, it's the standard ASP.NET MVC2 demo, Tailspin Travels, which I've seen at least 5 times this week, let alone TechEd in Australia last week. At the moment, it's just running off my local IIS, connecting to SQL Express. So it looks like this. I'm guessing everyone would have seen this at some point. And it's just a very small example of a line of business application hosted on the web. So I can log in, if I can remember the password. And then everything should hopefully be working. So yeah, all works. And this is ASP.NET MVC2. This is dynamic data. This is a few other things that you get out of the box as well. There's some WCF in there as well. So all I'm actually going to do is I'm going to take a new SQL Visual Studio instance. You have to run it as administrator to launch all of the local dev fabric. Even though I'm an administrator on the machine, I have to specifically tell it to run under administrator rights to do that. I don't know why my computer slowed down so much. It was fine earlier on. So once Visual Studio starts to respond, I'm going to click through File, New Project, and then I'm just going to set up the web project. I'm not actually going to demonstrate creating worker roles, but the process is exactly the same. So if I want to create a worker role, I go through this exact same scenario. So I'll create a new solution, which is TechEd Demo. Hit OK. It's worth noting here that each project I create within these roles actually spawns a new VM. So for cost models, if I decided I wanted to create a separate WCF service to a separate ASP.NET service, it's actually going to spin up 2 VMs and I'm going to get charged twice as much. So it's always worth that consideration, because if you could just host a WCF inside the ASP.NET web role anyway, and you would only get charged once. So I'm going to do an MVC2. The difference is it's the standard setup. You get an MVC2 project as opposed to an ASP.NET Web Forms project. Nothing else changes. And you also notice here I can do things like F#, CGI as well. Hit OK, and then it'll go off and it'll create an application up. Again, standard ASP.NET MVC project, as well as another piece of metadata within the solution. No, I don't want to create tests. These are the service configurations. So what this is actually defining is when it creates that bundle and sends it up to Azure, it's the amount of processing power I want, the amount of VMs I want to spin up, and things like the connection strings to the blob storage and SQL Azure. Okay, so I got an MVC web role. First thing I'm going to do is delete everything I get in there, apart from that one class. All of that is just the standard MVC stuff. So it comes up with that blue screen with welcome to my MVC application, hello world. So I'm then going to open up file system and just going to copy my solution, my other solution into here. It's a really unprofessional way of doing this, but it's the quickest way I could think of doing this demo. So I'm just going to open up 2 windows. And I'm going to copy everything apart from the bin directory and the stuff I don't need. Oops. I think that's everything. Copy that across, and then just literally paste it into here. Okay, so no code has changed. So all I'm going to do is I can now minimize that one because I don't need it no more. Come into here and just add everything back into the solution. So if my Visual Studio doesn't crash, this should now load up. It won't compile yet because I just need to add in some references to some specific assemblies that it needs, like the dynamic data ones. But after that, it should just run. Should, hopefully. Okay, you get the idea. I'm actually going to open up another project because this is just ridiculously slow. So I was building one earlier just in case things didn't go as well as I was hoping. I think it's that one. So it's exactly the same. It's all the same content. I haven't changed anything. All I've done is I've gone through, added in the references I needed, and then just changed some bits and pieces around. I have noticed when I copy and paste the entity framework stuff that it doesn't work always, so I've gone in and recreated that as well. But it's all the same code. So if I now hit F5, what will actually happen is instead of it spinning up a small IS instance or the Visual Studio Developer instance, it actually spins up a local instance of Azure on the Dev Fabric. So we can actually watch it go. So really, really quickly, it's deployed a web role, and again, it's opened up here. Somewhere, hopefully, it will also open up IE and run the application. So there we go. It's opened up on port 8080, which is just running on. Exactly the same as Cassini does. It runs it on a separate port, not to interfere with anything else on the computer. And hopefully, it will work. So this is essentially how easy it is to move an application to Windows Azure. There's no coding changes unless you're doing specific things like calling the file system. It's a matter of just bringing in a .NET 3.5 or .NET project across into a Visual Studio Cloud solution and just making sure it works. So again, this is still connecting to the local SQL databases. At this point, I haven't done anything around migrating my database to SQL Azure and testing against that. I just want to make sure that everything works as it's supposed to. So it connects off the local SQL, fine, and it should just let me log in. So I'm just going to quickly flick back to the slides. I'll come back to the demo in a minute, and then you can actually see whether it's logged in or not. So once we've actually done everything we need to do, and we've got an application together, we need to do some stuff around diagnostics and testing, and we actually then need to put it into the cloud. So the diagnostic availability of Windows Azure is exactly the same as if you were running it on IIS. You can do things like you can put traces in, you can get full hardware reports, you can get things like CPU utilization, memory utilization, and all of this is actually just written to a blob store. So if you enable diagnostics on Windows Azure, it writes everything back to what it knows as the file system, which you can open up in X Drive and analyze with the tools you're familiar with in .NET. You can also analyze these pragmatically. There's no reason why you can't create a worker process up that pulls this information in periodically, checks the utilization, making sure processor utilization, memory utilization isn't skyrocketing, and if it is, it will then spawn up extra instances using the API. So I'll flick back again. Sorry to keep going backwards and forwards. To this machine. You can see it's now logged in. Everything looks fine. So that class that I didn't delete, the web role class, is actually the only dependency on Windows Azure. The reason it's used is to actually provide functionality like the diagnostics code. So you override the role entry point, and obviously for a worker process, you create a worker role, and for a web role, you get a web role, and you just get a different base class. You override the onStart method, which is very, very similar to like the global ASAX, executes when the application starts. Let me just actually try and make this bigger. Can you guys see that? Yeah. So what we're looking at here is we're building what's called a diagnostic monitor configuration. So we're telling the Azure Fabric what information we want it to collect and then write back to our storage. At the moment, all of that's actually going to be written back to our dev storage. It's not going up to Windows Azure, so we're not getting charged for the storage costs. It allows me to make sure that everything's running fine, there's no memory leaks, and the CPU's going fine, and I can get any trace exceptions back written to log files. And all you do is you go through, and as you would in an ASP.NET application or any other .NET application, you configure the counters you want. So you can do things like processor, memory. I thought there were some others here as well. Obviously not. You then can go back in and add things from the Windows event log that's actually on the Azure VM. Things like application, security, system, and anything from an error level will get written back into these reports as well. You can define which periods you want these to arrive backwards and forwards from, and then you tell it where to store the information. So when you're dealing with storage, you have a connection string, the same as a database. So it just looks up where on the Windows Azure to actually connect that information through. So here's some more stuff, crash dumps and bits and pieces like that. And then once you've done all of that, you just then want to tell the diagnostic monitor to then start, passing your connection string information, and then it will go through and it'll start collecting bits and pieces for you. So as this actually, once I run my application, you'll actually start to see this work. So if I minimize my data collections here, so you should see in the blob storage a developer container open up which will have all my reporting in. And it just generate XML files for me, which I can then open up in things like trace monitor, in tracing tools to actually analyze. They're exactly the same as I get out of just a typical .NET application. That loaded up a little bit faster. Is there anything here? So now I get IIS log files. So if I double click on it, again, it's just like browsing directory, but this is actually on blob storage. I open up this, and it's a typical IIS log file, the same as IIS generates on Windows Server. But I'm not getting any performance reporting yet because I haven't actually done anything. But this is really, really useful when you're actually testing your application, making sure things work. And you can collect these once it's actually up in the cloud as well, so you can make sure that the healthy application is running fine. So the other thing we then need to do is actually look at deploying the app. So diving back into the Windows Azure portal, you actually have a very, very easy deployment experience. It's actually a lot easier than deploying to a typical IIS environment. You go in and you create a new service up, and you need to create one for compute and one for storage. These are all tied to billing, so you pay for a particular amount of storage and compute services, and then underneath you can then spawn multiple VMs. So in my Tailspin demo, you'll notice that this is deployed in Southeast Asia, which is our closest data center, and I believe it is actually Singapore. As of yet, we haven't got any data centers in Australia. The Azure appliance that was actually launched a few months ago actually allows people like telecom to host Azure instances if they want to. So we'll start to see some more local ones that are readily available. So once I actually build up a service, I then get these VMs spawned. The way they're spawned is, like I say, really, really easy. Right click, go to publish, and then I tell it I want to deploy on Tailspin production. I want to give it a label, so a timestamp, so I can roll back if I need to, and I hit OK. What this is actually doing is it's using my X509 certificate I've installed into the API and onto Visual Studio to connect to the APIs that are available, and then it's packaging up as what's basically a CAD file, pushing it up to the internet, and then Azure's taken over the rest. It's written all them configuration files. It knows I want one VM with a limited amount of processing power. It goes in, commissions that, spins up, takes about 5 or 10 minutes to actually deploy, but this is a lot quicker than me having to try and manually FTP stuff, configure IIS, configure application pools. So it's actually saying that I put one up earlier, do I want to delete it? Yeah. So it's now, this is all the history of my deployments. You're now seeing it's actually going up, and it will give you feedback here. It'll also give you feedback in the portal as well. So if I refresh this page, so you'll see it's busy, and it's actually commissioning the instance and spinning it up. The URL you see here is the CNAME it's given me, so I can go back into my own DNS and change that if I want to. And that's as easy as it is to get my MVC application from Windows, from an MVC application hosted on IIS into a web role, then moving it up onto Azure, enabling all the diagnostic tools and accessing them. I also moved my SQL database across and pushed it up there as well. So back to some more slides. So there's a few areas that I can't demonstrate because of time constraints, but are normally part of a line of business application that you need to consider. So what happens if you use Active Directory as an authentication, a search, or a profile mechanism? How do you get that onto Azure? So what you actually have to look at is something like federated identity. So you'd need to expose your Active Directory using ADFS, Active Directory Federation Services, and use a claims-based authentication to communicate back into your corporate network. This has some benefits because it allows things like single sign-on to happen, but it's very, very easy to do. This is all part and parcel of the Windows Identity Foundation API, which is a standard .NET API handling all the SAML tokens and the WS federated protocols, and it's part and parcel of Azure as well. If you don't have your own claims-based authentication provider, you can actually use the Azure App Fabric access control provider. And this allows you to use things like OpenID and other proprietary providers to actually connect into the system as well. The other thing we need to consider is how we deal with long-running processes, workflows, and interacting with other systems. This is where something like Azure App Fabric will come into handy. If we've got to interact with line of business systems that still sit behind their firewall and we don't want to risk exposing them via services, we can use the Azure Service Bus to build a small WCF client that sits in front of them line of business systems. The Azure Service Bus actually exposes everything via standard port 80 firewall port or an SSL port, pushes information up to Azure, and then allows two services to talk to one another on what is essentially a private VPN tunnel, but going through standard protocol. If we're dealing with long-running processes, we need to actually then construct things like message queues as well. We don't want to pass information off to worker processes without making sure that concurrency is being handled. Worker processes as well are set up for these long-running processes. So if we've got things like workflow, we don't want to push that onto a web role because it's going to be running up compute hours for us. We want to just push it off to a worker process, which will then just deal with one workflow at a time, it persists that somewhere, and then pass the message back by way of a queue. So the underlying question around Azure as well is how much does it cost? So when I've been playing around with some architecture stuff, I've been looking at exactly where the cost goes. So as you'll see by my nice pie chart, the majority of the cost on Windows Azure is compute power. You pay per compute instance per hour. So if I commission a VM, I commission a processor or multiple processors. All the time that role is up and running and it's sitting there with that hardware commissioned, I'm paying for it. So small, medium, large, extra large is the amount of processor power I get, the amount of dedicated processors I get. I can be charged up to $1.50 per hour for each time my application is up there. It's not, unlike some models, it's not the amount of usage of the processor, it's purely based on time. So this is where it really comes into its own, is if you build in your APIs to monitor utilization and automatically spin up and pull down VMs, as opposed to having human intervention there. I actually, when I first started playing around with cloud, went to Rackspace and I set up a VM. I totally forgot I set it up and it was running for 3 months. I got over $1,000 of credit card charges come through I didn't even know existed. So the next cost is SQL Azure. SQL Azure takes 36% of my cost, but this is done per gigabyte per month. So that answers the question earlier on around pricing models for Azure. It's not connections, it's per gigabyte per month. So when we actually look at the cost of SQL Azure, we pay for a maximum total hosting size of our database. When we was at TechEd Australia last week, we actually done the math. For the price of the biggest SQL Azure database you can get, which I believe is about 50 gigabyte, you can actually, for the price of a SQL enterprise cluster, you can actually pay for the biggest SQL Azure database you can buy for 15 years. So when you look at hardware longevity and licensing, SQL Azure actually cuts the mustard for that a lot better. And when you look at things like e-commerce systems and CMS that require clusters but they're not overly large, you're getting a better value for money on this. So the other thing we look at is things like storage and bandwidth. These are minimal costs. Any bandwidth internal to a data center is actually free of charge. You don't pay for communication into data center. So we're only dealing with the communication that's coming into our web role. So these are just HTTP SOAP requests. They're very small amounts of packets that are being transmitted. And we also are smart about this as well. We actually do things like we replicate to the CDNs, we remove latency, and we remove the demand and the bandwidth costs. The next cost is storage. So depending on what we're doing, storage is going to scale up, scale down. If we're building a new YouTube, it's obviously going to be a lot more expensive. But typically, blob storage is relatively cheap. It's designed just to be there as a file system and a persistence layer for Windows Azure. And it only accounts for 2% of our overall solution. What you need to take into account with Windows Azure storage as well is if you're using it for a CDN, you pay initially to cache that, to pull stuff down onto the CDN as well. So each time someone mirrors that content, you pay initially once for the total bandwidth transfer. And then after that time, you don't pay. So overall, the benefits I get here is I cut out my infrastructure costs, I cut out the cost of my sysadmins, my DBAs, and as a developer that just builds e-commerce systems, this is really, really simplified for me. I actually work for a company that has that owns several data centers, and the red tape and politics I have to jump through to spin up instances is really, really challenging. For me, I can do this based on an API, I can automate the whole thing, and get it done very, very quickly, very, very cheaply. It's designed for a specific purpose. It's designed to be there on lightweight apps, services that need the scale or the higher bandwidth compute power. It's not designed to run line of business systems and business critical applications, but for what it's there for, it does it good, it does it well, it does it cheaply, it does it efficiently. So we've all got a party to get to, so there's 5 minutes left if people want to ask questions, or if not, I'll let you get your party dresses on and head out. So at the back here.
If you deploy the code or you want to do backups of the data daily, how would you do that? You know, if you deploy the code, it's not good and you want to roll it back.
So the question's about recovering, rolling back instances of the code. So when you actually deploy to the server, it's exactly the same as if you deployed to a production server. It's just going to wipe everything off and then create it again. So the best way to do it would just be to use your own internal builds and actually have that accounted for in your builds. And then just have it, make sure that you have the last stable build archived somewhere. So if it does screw up, you can just revert back and push that one up. Any more questions at the front here? Yes, so the question's around costing the CDN. So you pay initially to pull it to the edge. Once it's on the edge, you then only pay per hit. You don't pay to copy it down each time. So once it's on the edge and it's been mirrored successfully, you don't need to pay any more data costs after that, apart from the incoming connection. So no inter-transfer fee is there. Does that make sense? Yeah. Yeah, so you define which CDNs you want it to go on. So if I want to replicate to the US, to Europe, and to Asia, I will pay for that 3 mirrors. So I'll pay each time I pull that file down and it's cached onto the CDN. and then I pay per connection to that CDN for people requesting that information. Any more questions? Okay, guys, it's party time, so have a good night, and I'll be around all day tomorrow if you want to ask anything else. Thank you.